So now in chapter 1, we are going to talk about the unit circle and sine and cosine functions. Okay. Now, in section 1, we are going to talk about angles. Okay, angles. Now, many of us may have experienced the angles, right? So the goal of this section is going to be how to draw angles in standard positions and convert between degrees and radians and find coterminal angles and find the length of a circular arc. Okay, so now let's see first goal. All right, so how to draw angles in a standard position. Now, before we talk about angles, we are going to introduce a concept called what? Array. All right, array. So what is array? The array consists of an endpoint on the line and all the points extending in one direction from that point. Now, for instance, I have a point, all right, and then all the points on the line extending to one direction. So for instance, somewhere here, so this is going to be array, all right? So you have a point and all the points in one direction, right? So from that point, okay, so you can have another one. So this one goes here. So this is another array, right? So this is the definition of array, okay? Now, the first point, now the endpoints, right? This endpoints is called the, it's called the endpoint of array, and we refer to a specific array by stating its endpoints and any other point on it. Okay, say for instance, if this is endpoint is A, and I have another point, all right, in the another point on the line, on the array, okay, B. So then we will just say this array is denoted as AB arrow, right, on the top of them. Okay, so this means what? Array with endpoint A, okay, and pointing to the direction of B, right? So A is the endpoint, B is another point on it, right? B is another point, all right? So for instance, if this is C and this here, there's a point D, then we will say this array as C, D are endpoints, okay? Now, now be careful. This B is any point on the array except the endpoints. All right. So A is the endpoints. B is a point on the array. CD means C is endpoint and D is a point on the array. Okay. So after we define this is an array, okay. So then we're going to define angle. What is the angle? Right? So an angle is a union of two rays with a common endpoint. All right, with a common endpoints. Now, for instance, this is a ray. Okay, say this is A, and so ray AB. All right, and when a union of two rays with a common endpoints. So, for instance, here's another one, right? So, hey, say this is a C, right? So A is the common endpoint, and you have two rays, right? So AB and AC. So, and then the union of these two is an angle, okay? Now the endpoint is called the vertex of the angle, and the two rays are called the sides of the angle. The sides of the angle. So AB is one side, AC is another side, and we have what, two rays, right? And then A is called the vertex of the angle. Okay. Angles can be named by a point on each ray and the vertex, for such as the angle DEF, or in the symbol D, angle DEF, where E is the vertex. Okay. D is a point on one side and F is a point on another side. So for instance, if I have an angle like this, say this is D and this is E, and this is F, right? So then the angle E, oh, well, sorry. E is the vertex. Okay, let's just say this. Okay. Here is E. Now this is D, and this is F, right? So E is the vertex. So E is in the middle, and you have D on one side. E is the vertex, and F is a point on the other ray. All right, so make sure that this vertex is in the middle. Okay, the vertex is in the middle. All right, the vertex is in the middle. All right, so now, how about this one? How do we denote the angle here? So here, what is the vertex? A. So this notation of this angle is going to be what? Angle B, A, C. Is there another way to denote this one?
CAB.
CAB. Yes, right? So they just say what? D is a point on one side, F is a point on another side. You can just use CAB as well. It's the same angle, right? So, okay, so this is going to be the angle here. All right, so very good. All right, so just to make sure that the one in the middle is the vertex, right? The one in the middle is the vertex. Now, in many cases, we also use the Greek letters to represent angles. All right, so for instance, here are some common Greek letters that are usually used for angles. Like this one is called theta, phi, alpha, beta, gamma. All right, so these Greek letters, they are often used to represent angles. All right, so in those cases, we use what? Angle theta, angle beta, angle alpha, angle phi, and so on, right? So these are in other notation. Now, in many cases, they are going to do that like this. The angle is alpha, right? So now you can also draw another one, and then this is going to be, say, theta, right? So now these letters, Greek letters, alpha, theta, they represent these two angles. Okay? Now, angle creation, all right, angle creation. So how to create an angle, right? So as we know, there is a vertex, all right, two common rays with a common vertex. And here, in many cases, especially in real life, all right, so we have, we commonly have angles, right? There are a lot of, if you have a slope, right, there is an angle between the slope and the horizontal, the horizon, right? So there are many different cases of angles we use. Okay, so now for angle creation, we usually have an initial side, which is a ray with a common, right? Let's say this. This is our initial side. All right, so this one is initially here. Okay, so what we want to do is we will put this initial side in one of the direction. For instance, we will do this one upwards. Now, but by fixing the vertex. All right, so for instance, we rotate this one somewhere here. All right, so and then we are going to get an angle here. All right, so this is the resulting or the ending side is called the terminal side. It's called a terminal side. Okay, so initial side and terminal side. Then we also have the measure. Okay, so as you can see, you have an initial side is where you start with, and then you rotate this initial side all right, with the vertex fixed, all right, you rotate it, right? And then at some certain point, you release it, all right? And that resulting slope is the terminal side, okay? Now, however, as you can see, right, by this angle creation, sometimes you can have a small angle, right? The rotation is pretty small, but sometimes you can rotate a large angle, right? You have a large rotation. Then you will result in a large angle, right? Now, also, you may have a full revolution, right? Full revolution, right? A full circle. Then you come back to the initial side, right? Or sometimes when you got a full revolution, then you do another, right, angle. You go beyond that, all right? You take one circle and then do another, right? And so on. Now this rotation can be what? Small or large, right? And there are or in either in this direction or then clockwise or counterclockwise, right? So you can do that in different directions for different sizes. All right, so this is the angle, but okay. Now you have initial side, a vertex, and a terminal side. That's how we create an angle. Okay. Now the measure of the angle is the amount of rotation from an initial side to the terminal side. That is the measure of the angle. So to measure the angle, the measurement of angle, you need to determine what? The initial side and the terminal side. And then what? This amount of rotation needed from the initial side to the terminal side. So this amount of rotation is the measure of the angle. Okay. Now, as we said, okay, this is the measure of the angle and its amount of rotation. How do we measure this angle, right? You said the amount of rotation. So how to measure the amount of rotation? Well, that's another interesting question, right? So now in order to measure the amount of rotation, we introduce some concepts. Okay, so one is called a degree, another is called a radian. Okay, so let's firstly consider degree. I believe many of us may have come across with this concept, or the degree in the notation is just a circle, superscript, okay, circle here. Okay, so it's a unit for measuring an angle. 1 degree is 1/336 of a circular rotation. In other words, there are 360 degrees in a complete circular rotation. All right, so this one's here, right? So now if you just take a rotate it and then come back, this is what? 360 degrees. All right, that's a full rotation, a circular rotation, a complete circular rotation, 360 degrees. Now, then 1 degree is going to be what? 1/360 full circular rotation, right? Circular rotation. All right. Now, in other words, okay, 360 degree is what? One
rotation.
Yeah, circular rotation. Then So then for what about say 10 degrees, right? 10 degrees is going to be 10 times 1 degree, right? Which is going to be by substitution, 1 degree is 1 over 360 circular rotation. So this is going to be 10 over 360, right? Or 10 times 1 over 360, right? Circular rotation, right? So which also equals 1 over 36 circular rotation, right? Okay, and so on. Now, there are some very interesting ways, all right, to measure this one. So for instance, I'm just, can you find how many circular rotation in, say, 90 degrees? 90 degree equals how many circular rotation? Or what kind of circular rotation equals this, 90 degree?
1/4.
0.4. Or you mean 1/4?
1/4. So 0.25.
0.25. How do you get that? It equals what? 90 degree equals 90 times 1 degree, right? So which equals 90 times 1 over 60, right? So circular rotation, so it's gonna be 90 over 360, which is 1 over 4, right? So if you use a calculator, you can find this is 1 over 4 circular rotation. Now, right? So now, what is 1/4 of a circular rotation? So let's just put it here, all right? So I'm going to, okay, to draw it here. Okay, so let's say that here. I'm going to draw it here. So 1/4. Now in the full circle is 360. So 1/4 of it is here, right? It's just one part of it, right? It's a right angle, right? So it's 90 degrees right angle, which is 1/4 of a circular rotation. Does that make sense? Good? Okay, very good. All right, so there are, later on, we are going to get familiar with all this later on. Now, then we are going to talk about the so-called standard position. All right, this is XY. It should be shorter, XY coordinate plane, or XY coordinate plane. Okay, so I'm going to just draw this one here. It is, you have x-axis, you have a y vertical axis named y. So they are straight. Y, all right, so you have unit 1, 2, 3. Here's 1, 2, and 3. Okay, so something like this. It's going to be -1, -2, -3, -1, -2, and -3. Okay, so basically this is a sketch of the XY coordinate plane. You have a horizontal axis, which is also called x-axis, and it has a vertical axis, which is also called y-axis. And then on each axis, there is a unit of 1, 2, and 1, and then these are the numbers marked on the axis. Okay, so this is XY coordinate. Now, in order to get the standard position of an angle, we mean standard position by what? The vertex of the angle is located at the origin, so which is 0, 0. Origin is 0, 0. Okay, and the initial side extends along the positive axis. All right, so let me just draw this one here again. So you have here is my x, here's my y. Now the vertex is at the initial origin. Our origin is 0, 0 here. I say this is 1, this is 2, 3, 4, 5, -1, -2, and here is x is 0, and for y, 1, 2, -1, -2. Now y is also 0. For this point is going to be the vertex. You put the vertex of the angle at the origin. Okay, and then what? The initial side extends along the positive x-axis. So the initial side should be the same as what? The x-axis. And the other terminal side, that's going to be the initial side. And this is the vertex. Okay, and then you have another, well, sorry, better not to do this. Okay, so another terminal side, okay, is somewhere else. Terminal side. Okay, terminal side. So this is called the standard position of an angle. All right, you just draw a xy coordinated plane, and then the initial side, the vertex should be at the origin, which is 0, 0, and the initial side is the same, extends along the positive axis. Okay, and then this angle is called the standard, or is said to be at the standard position. Okay, so if a question is asking you to draw the angle at the standard position, then that is what we mean. Okay. So how to draw an angle in standard position? Okay, so we firstly draw an angle along the positive axis, right? So, and then calculate the fraction of a full rotation. All right, so like what we did, like 90 degree is 1/4 of a full rotation, right? And then, okay, you calculate that. All right, calculate the fraction of a full rotation angle represented by dividing the angle measure in degrees by 360. Okay, and then rotate the terminal side counterclockwise, right? Counterclockwise to the desired location. Okay. Now let's consider an example here. Okay. Let's see. Natalie, can you read for us?
Drawing an angle in standard position measured in degrees. A, sketch an angle of 30 degrees in standard position. B, sketch an angle of -135 degrees in standard position.
Very good. Thank you, Natalie. That's very good. Okay. Now let's consider this one, right? So how are we going to do this? Right, I'm going to firstly do this A together, and then I will like you to sketch the B. All right, so consider A. All right, consider A. Now, firstly, what we do is we are going to follow this step. Draw the initial side along the positive axis, right? So we are going to have something, an XY plane. Okay, so here is X, here's Y. Say this is 1, this is 2, and this is 3. -1, -2, 1, 2, -1, -2. And this is the origin, right? So now we have this. So this is our first step. All right, let's say that the positive x-axis is the initial, is going to be the initial side. All right, this one. And then we want to sketch the angle of 30 degrees in the standard position. So what we need to know is what? Calculate the fraction of a full rotation, right? So we know that 1 degree is 1/360. So what is the fraction of 30 degrees?
30 over 60.
Can we find the fraction of 30 degree of a full circle, of a full rotation? So
1/12.
1/12. All right, so we found this one using what? 30, well, over what?
360.
60. All right, which equals 1/12, right? 1/12. Now, I would like to draw this 1/12 of a full circle, but if you see that 1/12 of a full circle is not quite easy to see, right? So you have to separate this full circle in 12 equal parts, right? And then draw one of them, right? So it's gonna be not an easy problem. Now what we can do, all right, since this XY axis, you see that, right? There are 2 lines separating the full circle into 4 parts, right? Into 4 parts. So each part is a right angle, right? Each part is a right angle. So for instance, this is 90 degrees, right? That's 90 degrees. We know that. Okay. So now, and then this is also 90 degree, but if you add them up, that's going to be 180, right? And so on. So what I want to do is, we know 90 degree is 1/4 of a full circle, right? So now it's better, all right, to write this 1/12 into a fraction of 1/4. So what is a fraction of a quarter is 1/12? It seems like we can do 1/3 times 1/4. Is that right? Is that right? Okay, I think this is right, right? 1/3 times 1/4, that is 1/12. Okay, 1/3 of a 1/4, right? 1/3 of a quarter, that is 1/12. Now, if you're unsure about that, you can check the calculator. This is true. Okay, so which means that is 1/3 of a quarter. 1/3 of a quarter, right? So then it becomes easier, much easier, right? So what we can do is just to separate the first angle, right, right angle into 3 parts, right? Into 3 parts. For instance, let me just sketch. All right, this may be one of them. Okay. All right, so I will see that. Okay, so these 2 lines will separate the 90 degree into 3 parts, 3 equal parts, and then what? Now because I'm doing 30, right? So it's gonna be this one. This is gonna be, this degree is gonna be 30 degree, right? Okay, so now here is what we do, right? So we know that we start with the XY coordinate, right? Starting the vertex is at the origin, and the initial side is come along with the positive x-axis, and then we found out the fraction of a full rotation of for the angle, right? 30 degree is 1/12 of a full rotation, but we can also express 1/12 as 1/3 of a quarter, right? And then we can find out the location, right? Rotate the terminal side counterclockwise to the desired location. Now, this is for positive degree, all right? For if this is a positive degree, we rotate counterclockwise. As you can see, we are doing what? This rotation, counterclockwise. Yes? Okay. Now, this is how we do this. All right, we got A. Now, if we got a negative degree, what we are going to do is we're going to rotate what?
Clockwise.
Clockwise. Very good. All right. So for instance, in B, all right. So instead of what going clockwise, we're going to do counterclockwise. All right. So B. How about you? I would like to see if you can solve for this one. So B. All right, go ahead and try if you can sketch the angle -135 degree in standard position. See if you can do that. Okay. All right, let's do this one together. All right. So some of us may already got this one. All right. So, but let's do this one together. Firstly, did you get this one? This is -3/8. Is that good? Okay, we got this, right? And then basically we want to separate this one into this one. But again, 3/8, so that's 3/8, -3/8, right? So it's really better to express this -3/8 into multiples of quarters, or some addition of quarters. All right. So now we can express this -3/8 into what? Into -2/8 minus 1/8. That's the same thing, right? Does that make sense?
Mm-hmm.
Okay, that's the same. Now for the first one, -2/8, it is what? -1/4. Yes?
Yes.
It's just a 1/4, right? -1/4. Okay, very good. And then -1/8 can be written as -1/2 of quarter. Yes? Okay,
Yes.
so it's like addition of two parts. You firstly go 1/4, right? -1/4, clockwise. right?
Mm-hmm.
And then go another what half of a quarter counterclockwise, right? So then you got that point, correct? Okay, so how can we do that? All right, so let's just draw the location of the terminal side by going what? Firstly, -1/4. So that is going to be the negative y-axis, right?
Yes.
And then you start by half of a quarter. You know, the half of a quarter is going to be what? Just in between this one, right?
Mm-hmm.
Okay, so then you move on for another 1/2, and then this is going to be the terminal side of this angle.
Mm-hmm.
Got it? Okay, very good, very good. All right, so now here is a technique. All right, it's usually good to express. Firstly, find the fraction of a full rotation, and then what? And then write this fraction as multiples or fraction of quarters. All right, or either multiple or fraction of quarters, like this one. You go 1/4 and then go half a quarter, right?
Mm-hmm.
So this is sometimes you know, as a key part of a solution to these type of questions. All right, so all right, so this is this type of question. We want to draw an angle in degrees in standard position. Okay, so very good. Now let's just draw some very special angles. All right, very special angles. The angle is a quadrantal, right? Quadrantal angle if its terminal size lies on an axis, including these ones. All right, so these are some special type of angles. Here's my x-axis. Here's the y-axis. Here is this one. All right, so 1, 2, 3. -2, -1, 2, 3. -1, -2. All right, so you got this xy coordinate. All right, and then the zero angle, 0 degree is going to be just a special angle, just lies on this positive x-axis. So, and 90 degree is going to be just the right angle, and the terminal side lies on the positive y-axis, right? Positive y-axis. And then you got an 80 degree, 180 degree. That's going to be the negative x-axis, right? Negative x-axis. And then 270, that's going to be the negative y coordinates, right? So you have what? This is 90, and this is going to be 180. And then if you go here, all right, that's going to be what? 270 degrees, right? But if you go all the way around and comes back, that's a full rotation, right? That's a full rotation, which is a 360 degree. Okay, so you have 90, 180, 270, and full rotation, right? So these are going to be what? If you go 90 degree, then you end up at what? The positive y-axis, positive y, right? Positive y-axis here. If you go 180 degree, that's you end up at the negative x-axis, and then 270 is negative y-axis, and then 360 you come back to the positive x-axis. All right, so this is the quadrantal angles. All right, quadrantal angles. Now, for any angle in between, all right, let me just draw another one. All right, I'm not going to. Okay, here's x, here's y. All right, so this is 1, 2, -1, 1, 2, -1, -2. Now, as we know, right, this is 90 degree, right? This is 90. Then what about any angle in between? It's going to be between 0 and 90, right? This angle is going to be what? Alpha. So alpha is going to be greater or equal than 0, less or equal than 90. Yes? So in the first quadrant, this is going to be in between 0 and 90. Or you can say alpha is greater than 0, less than 90. Yes? That's someone ending up at the first quadrant. Okay? So for an angle ending up in the second quadrant, that's going to be between what? Here it's going to be alpha is greater than 90, but less than what?
180.
180. Very good. Okay. So if an angle ends up here, then it's going to be what? Alpha is greater than what?
180.
But less than 270. Yes? Less than 270. Okay. Now, finally, if it is in this quadrant and it goes counterclockwise to here, then this alpha is going to be greater than 270? Yeah, 270, but less than 360. Yes, right? So you need to know this, right? Given an angle, you need to know roughly where it's located, right? If it is between 0 and 90, first quadrant, right? Between 0 and 90. If it is between 90 and 180, second quadrant, right? Second quadrant, between 90 and 180, right? If it is between 180 and 270, then it's the third quadrant, right? In the third quadrant, it's the opposite of the first, all right, in that location. And then finally, if it is between 270 and 360, in the fourth quadrant, somewhere there. Okay, very cool, right? So this is the how we can use the quadrantal angles to get a roughly position, right? To roughly position our angle given its degree. And then we are going to talk about arc. Okay, so as many of us have learned, right? What is an arc? Now here we are talking about the circular arc, right? The circular arc, the arc of a circle. Now, the arcs can be what? Can be from a circle, can be from an ellipse, and from other shape of arcs, arch. Oh, anybody want to? Anybody had visited this St. Louis? No. There is but have you heard about there is a national monument called what? The arches in St. Louis. In St. Louis, all right. We visited there. And it's a big arch, right? The arches, national. I think it's a national monument, and really impressive. Okay, so that's a type of arch or arc. Okay, but here we're talking about the arc is about the arc of a circle. All right. So anybody know the circumference of a circle? Anybody heard about that? The circumference equals what?
2 pi r.
2 pi r, where r is the radius, right? Where r is the radius of this one. C is the circumference, right, of a circle. Pi is what? 3.14. Something like this, all right? Something like this, right? It's an irrational number. Okay. 1592345. Okay, something like this. All right, so this is a circumference of a circle. All right, so we know that. All right, given the radius of a circle, we can find its circumference. All right, that's the length of the full circle. All right, the arc of a circle is going to be part of the circumference. All right, part of a circle between a pair of distinct points on the circle. All right, so I'm going to draw a circle with a center, something like, say this is A, and say this is B. All right, so you have two parts, 2 points, two distinct points, and then this part of the circle is an arc of a circle. Now be careful, it's not this one, all right? These one are not included. It's not a pi, all right? It's just the arc, just this part, all right? Just this part. That's the arc. Okay. Now here, the arc is gonna have a length, all right? You can measure the length of an arc, all right? You can measure the length of an arc. Okay. Now, for the length of the arc, you can get something really interesting. Okay. So, what is the length of an arc? All right. What is the length of an arc? So, now we have something here. All right. The arc of a length, and then sometimes we are trying to find, okay, so what about if the arc length equals the radius, right? If the arc length equals the radius, what kind of that? Now you see that this comes as the definition of radian, all right? It's a measure of a central angle of a circle that intercepts the arc equal in length to the radius of that circle. So it means what? It means, okay, so you firstly have a circle. You have a circle here, right? I'm going to just draw this one, all right, a circle. And then what I'm going to have is, say this is a point, A, right? Now this radius, given a circle, we can measure its radius, right? Now we're going to have a radius, have an arc equal in length to the radius of that circle. So basically, for instance, we can find a point somewhere here, say that B, right? Mm-hmm. Now this arc in length is the radius. This is one radius. Okay, if this arc is 1 radius, then as a corresponding central angle of this arc. Okay, then we define what? This angle, say this angle is alpha, right? So then alpha is going to be just equals what? 1 radian. Does that make sense? Okay, so you go 1 radius and you got an radian, or 1 radian, okay? Then, so if you move on for another radian, you can add another radian, right? Maybe somewhere here, maybe somewhere here, all right? So here's C. Right, so this is center is O, right? So you can add another radian, then that's going to be 2, right? That's going to be the 2 radians. All right, 2 radians is going to be from here to here, right? Mm-hmm. And then you can just add another one and another one, so on. But as we know, all right, this arc. This arc can be any length, can be of any length, right? Sometimes it's a multiple of the radius, but sometimes it may be a fraction of the radius, right? Say, what about, say, an angle beta equals 1/2? That means what? That means it is a half of an arc, right? Half of this one, right? Half of one, so which is 1/2. Okay. Now, when an angle is described without a specific unit, okay, like this one, alpha equals 1, beta equals 1/2, right? So when an angle is described without a specific unit, it refers to radian measure. Okay, it refers to radian measure. Okay. Now, for instance, an angle of measure 3 indicates 3 radians, right? Now, which one is larger? 3 and pi. Which one is larger?
Pi.
Pi is what? 3.1415 something, right? So we know that pi is greater than 3, right? Pi is greater than 3. And as we know, the circular is what? The circumference equals 2 pi r. Yes? The circular, the circumference is 2 pi r. So in other words, I know that the circumference of a circle is 2 pi r. Then what is the radian of a full circle?
Would that be 2 pi?
That's going to be 2 pi, right? That's going to be 2 pi because the circumference is 2 pi times r. 1 r is 1 radian, right? 1 r corresponds to 1 radian. So the full circumference corresponds to 1 full rotation equals what? 2 pi. Yes? Equals 2 pi. If 1 full rotation is 2 pi, then what about a half of a full rotation? Half of a full rotation is going to be what?
Pi.
Just pi, right? Just a pi. So which means what? The semicircle on the top, right? That's the length is going to be pi r, right? The length is going to be pi r. So the correspondingly, this angle is what?
180.
180 degree, right?
Yeah, about pi radians.
By radians is going to be what?
Pi.
By radians is going to be pi, right? Because the full rotation is 2 pi, then half of a full rotation is going to be simply pi, right? But as Mustafa also mentioned, it's 180, but 180 is in degrees. It's not in radian, right? So as we said here, 180 is also half of a full rotation, but this 180 is in degrees, right? It's in degrees. Okay. Here pi is in radian. Right? It's another unit for the angle, for measure of angle. Okay. So this is going to be pi, all right, half this one. So for 3, a measure of 3, if alpha equals 3, so it is going to be close to pi, but smaller than pi, right? But smaller than pi. So it should be something like this, right? Now this angle might be 3, right? Might be something like that, 3, right? So you may see that because 3 is less than pi. Pi is a half circle, right? Pi is a half rotate for half full circle. Then 3 is a little bit smaller than pi, so we can see that this 3 maybe just a little bit, there's a small shortage here before it comes to pi, right? So it's something like this. Okay, so this is in radians. Okay, now let's just draw angle in standard position and radians. All right, so let's say Mustafa, can you read for us, please?
Drawing an angle in standard position measured in radians. A, sketch an angle of 1 in standard position.
B.
And B, sketch an angle of pi/2 in standard position.
Very good. All right, very good. All right, so can you do that? All right, so again, right, so you have to be careful. Your standard position, you need to start with XY coordinates. Okay, so you want to sketch it, right? So you sketch it. You just make a sketch of this XY. Here's X, here's Y. 1, 2, -1, -2, and 2, and -1, maybe -2. Okay, so this is the XY coordinate. And you want to draw an angle 1. 1 is a positive, right? 1 is positive. So how do we draw this one? All right, it's better to start with the unit circle. All right, unit circle here. This is going to be somewhere 1, right? So 1 is should be somewhere here. Like this one should be in the length of 1, right? This arc should be of length of 1, right? So you can just anticipate somewhere here with this length equals what? Equals 1, right? Mm-hmm. Equals 1. So, and then you can just connect it. So this is approximately, we just sketch it, right? So this is going to be an angle of 1, or angle 1. All right, so something like this. The terminal, you determine the location of the terminal side by measuring what? This length of 1, with the radius is 1, length is 1, right? We got that. Right. Now, similarly for B, okay, so can you find the angle of pi/2?
If pi is half of that would be vertical. It would be vertical, wouldn't it? It would be up the positive y, right?
Yes, exactly. I like that, Nick. Okay, I like that. Yeah. Okay. But Nick, can you repeat what you said again?
It would be vertical because pi is 180, so it would be half of that would be 90 because it would vertical would be a quarter of a circle.
Yes. So pi is half of our circle, right? It's a semicircle, pi, right? Then pi/2 is going to be a half of a half, right? So that's 1/4, correct? 1/4. Yes. So therefore, it's going to be just to go to what? This one. Lands on this, right? Lands on this. Okay, so if this is 1, this should be pi/2, right? Mm-hmm. So very good. Okay, this is pi/2. pi/2. Okay, very good. Okay, now of course, if we give other measures, like say pi/3, mm-hmm. If it is pi/3, then where is it going to be? You separate the half a circle into 3 parts, right? Mm-hmm. Into 3 parts. And then, for instance, it should be something like this, right? So this is 3 pi/3, pi/3. So in total, it's pi, right? So then this is going to be pi/3, right? Mm-hmm. Okay, and so on, right? And so on. If you divide pi over 3 into halves, that's going to be what? Pi over 6. Yes?
Yes.
Divide pi over 3 into halves, that's pi over 6. And divide pi over 6 into halves, you got pi over 12. Yes? Okay,
Yes.
and so on, right? So you can play with it, or you can play with it, and you can get some really interesting observations from this. Okay, but later on we are going to talk about all this. But as for now, you need to know how to sketch an angle measured in radian in standard position. Okay, so that's going to be very important. All right, now as you can see, we have two measures or two units. One is in degrees, another is in radians, right? Now it comes naturally, how can we convert between radians and degrees, right? So as we know, we can do this one by this equation, right? As we know, a full rotation is 360 degrees, which is also what? 2 pi radians. 2 pi radians. Okay? Now, then we can find, all right, we can find for any angle, all right, for any angle with okay, theta measure of an angle in degrees. All right, and let theta r be the measure of an angle, of the angle, of the same angle in what?
Radians.
In radians. Okay, in radians. I have theta and theta r. Okay? Then they should be the same because they're of the same angle, right? The amount of rotation is the same. So we should have what? Theta equals, well, no. Okay. We should have what? The fraction of a full rotation should be the same, right? The amount of rotation should be the same. Amount of rotation is the same. Yes, because it's the same angle, right? It's the same angle, so the amount of rotation is the same. Now, what is a fraction of theta in degrees of a full rotation? That's going to be theta over 360. That is a fraction of the angle of a fraction of a full rotation, right? If we measure it in degrees, it's going to be theta over 360. That's the fraction of the angle in degrees, right? So this is the fraction of a full circle, the amount of rotation, right? Okay, theta over 360. Now this fraction should be exactly the same as the fraction, what? Theta r over 2 pi. Because what? 2 pi is a full rotation, right? 2 pi is also a full rotation, correct? Okay, so theta r should be over 2 pi, and theta, this fraction is the fraction of the angle from a full rotation, right? Theta r over 2 pi. Theta over 360 is also the fraction of a full rotation for this angle, right? So they're all measuring the same amount of rotation. So these two fractions should be exactly the same. Does that make sense?
Mhm.
All right. Then if we multiply 2 on both sides of this equation, see what we get. All right, if I multiply 2 times theta over 360 equals 2 times theta r over 2 pi. All right, let's see that this on the right-hand side, it seems that 2 and 2 cancel out. Yes?
Mhm.
On the right-hand side, 2, 1/3, 360, here remaining what? Theta over 360 over 2 is what?
180.
Okay, very good. Right? Theta over 180 equals what?
Theta
R
r.
over pi. Okay, now we have come up with this theorem. All right, this theorem gives us this equation to convert between radians and degrees. Right? To convert between degrees and radians, we use the proportion, this one. All right, so where theta is a measure of angle in degree and theta r is a measure in radians. Does that make sense?
Mhm.
Okay, very good. This is something we are going to be using quite often. All right, so this formula is very important. We should memorize this one. Theta over 180 equals theta r over pi. Okay, so memorize that. Okay. Okay, I think is that time, right? It's already time, right?
Yes, I think.
Natalie, yes?
Yeah.
Yes, I think it's it's one what? Okay, I believe it's the time. It's I believe it's time, right?
I think so.
Okay. All right. Let's see. Okay. Yes.